Factoring quadratic trinomials. In the previous episode, we factored quadratics that had a leading coefficient, or a, was equal to 1. We used the x method. We took a times c and placed it here, and placed b there. We then found two factors when multiplied together to give you a times c, and when added together to give you b. And since the leading coefficient was equal to 1, we knew it was x plus something times x plus something. So today we'll be factoring when the leading coefficient is greater than 1. So it's a little more complicated, but it's the same procedure. We'll just add a few more steps. So as you can see, we're going to draw our x. We're going to take a times c and place it in the top here. Place b here. We're then going to calculate the two factors, just like we did yesterday. But we're going to add one more step. Once we've found the two factors, we're going to divide each factor by a, then reduce it if possible, and then we're going to take the denominator of the fraction, and that will become the coefficient of the factor. So let's look what that means. So here we have number 36, 3p squared minus 2p minus 1. So I'm going to draw an x. I'm going to take a times c, which is negative 3, and I'm going to put b here, which is negative 2. So what are the two factors of negative 3 that add to negative 2? Well, 3 and 1 are the factors of 3, so one of these has to be negative. To get a negative 2, the 3 has to be negative. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. All right, so now we're going to add the next step. We're going to then take the leading coefficient of 3, and we're going to divide each factor by that. And then we're going to reduce. 1/3 is reduced. This one isn't. So we're going to go ahead and write that as negative 1 over 1. So now we can factor. So we're going to have, this is our coefficient that goes with our variable. So we're just going to have a p, 1p, and then minus 1. And then here we're going to have 3p plus 1. And if we FOIL, we'll get what we started with. Let's go to 38. So let's start by drawing an x. And we're going to take 4 times negative 7, which is negative 28. We're going to place the b of negative 12 here. And now we're going to come up with factors of 28 that equal 12. So I know 14 and 2. All right, to get a negative 12, I'm going to have a negative 14. So they multiply to give me negative 28 and add to give me negative 12. Now I'm going to divide by the leading coefficient of 4. And I'm going to reduce. So this is going to equal 1/2. And this is going to equal negative 7/2. So my factors are going to be 2x minus 7 and 2x plus 1. Okay, number 35. All right, so we're going to factor it. In this instance, we're going to end up with a big number here. So let's see, we might have to add a step. So we're going to take a times c, and we're going to see 5 times negative 24 is negative 120. And then the factors of negative 26, or the factors that add to negative 26. So let's go ahead and use our calculator for this. I've put in y1, negative 120 divided by x, and I've told y2 to add x and y1. So since I did that, now I can just look in the y2 column and find the factors that add to a negative 26. And they are 4 and negative 30. So we have 4 and negative 30. And now we're going to divide by the leading coefficient of 5. And that's good. And 5 here, so we can reduce this to negative 6 over 1. So then my first factor becomes 5x plus 4. And my second factor becomes x minus 6. All right, 37. We're going to start by drawing our x. We're going to take a times c, which is 6 times 25, which is 150, and write our middle term here. So what are the factors of 150 that equal 25? Well, you may be able to figure that in your head, but let's pretend you can't. So we'll go into our calculator, we'll put 150 divided by x, and I already have it set up. So now I'm looking in the y2 column for 25, and I see here, so 10 and 15 are my factors. Now we're going to divide by the leading coefficient of 6, and we're going to reduce. Divide by 6, and we're going to reduce. And now we're going to write our factor. 3x plus 5. And 2x plus 5. Okay, let's add one more step. So anytime we're factoring, we should always look to see if we have a greatest common factor. And we should factor that out first to make this smaller, and then proceed. So here we have 12, 50, and 50, so I can factor out a 2. So 2 times 6n squared plus 25n plus 25. So 6 times 25 is 150. And then we have the 25 here. So what are the factors? Are going to again be 10 and 15. And we're going to divide by the leading coefficient. Not this 2, this has just been factored out. We just factor him out and then he comes back at the end. So the leading coefficient is 6. So 5/3. Leading coefficient is 6. Divided by 3 is 5/2. So again, my factors then are 3x plus 5 and 2x plus 5. And then I put my answer here. The 2 that I factored out. All right, number 42. We're going to first see if we can factor out a greatest common factor. And the greatest common factor of 16 and 140 is 4. Let me show you how to do it on the calculator. You go into Math, go over to Numbers, and then hit number 9. GCD, greatest common factor, greatest common denominator are the same thing, just in the context you use them. So we want to see the greatest common factor of 16 and 140. So we can only really do one at a time, at pairs. So 16, 140, close your parens, And they'll tell us 4 is the greatest common factor. So let's factor out a 4. So that makes it 4n squared minus 4n minus 35. All right, now we can start. What are the factors of negative 35 times 4, which is negative 140? That's a coincidence there. And then a negative 4. So the factors of negative 140 that add to negative 4 are 10 and 14. You might have already known that. 10 and negative 14. And then divide by your leading coefficient, not the factored out, this one here. And that will give you 5 halves. And that will give you negative 7 over 2. So my factored would be 4 times 2x plus 5 times 2x minus 7.